I'm Casey, and welcome to an exhibit spotlight. The sand pendulum is one of our most popular exhibits. Kids love coming over here and filling it up and then woo! Fluing the sand all around. But do you know what it actually does? This is actually showing really complex mathematics and geometry and showing the beauty in math. Let me show you what I mean. So this is a pendulum. A pendulum is just an object suspended from a string in a way that it can go back and forth. The amount of time it takes for that object to get from point A back to point A is called the period. Now, if I start with a nice smooth surface and just let it go, it's going to go back and forth. And it seems to be making a kind of funny line. What's up with that? Well, looking at it, this is not your ordinary pendulum. See, it is suspended by one rope, but actually this one is suspended by two ropes. There's another rope going across, and then this one is hung in the middle. And that's going to make some interesting things happen. If I stand where my ropes are lined up, it's going to act just like a normal pendulum. It's going to go back and forth, because the only thing happening is just this one thing. Back and forth, relatively straight line. Same thing if I try and get exactly perpendicular. Relatively back and forth, straight line, nothing really interesting happening. But if you notice, we actually have 3 points of contact. So if I take my pendulum and move it so that now I'm at an angle, now I have 3 different periods to deal with. The length of this string, the length of that string, and the length of that string. And each period is going to take a different length of time, which means it's going to make my pendulum swing in a different pattern. Now the really cool thing is these patterns are predictable. They're called Lissajous curves, and they're used to find wave patterns in all sorts of oscillations, like sound waves, light waves, or in this case, seeing actually the rotation of the Earth. If you change where you let it go, you're going to get a different shape. So the next time you come to the museum, don't just fill it up and swing it all around. Try an experiment. Can you find the perfect place to make the most beautiful Lissajous curve? Thanks for joining me for an exhibit spotlight.